Hello everyone, I'm Tingjie, a PhD student from Liangyuting Liverpool University. I'm glad to present our work, Exploration of Food-Based Text Entry Techniques for Virtual Reality Environments. Virtual reality has transformed our interaction with digital content, offering immersive experiences across various domains. As VR continues to evolve and gain wide adoption, the needs for efficient and natural text entry method becomes increasingly crucial. Handheld controller and hand gestures are the predominant means for text entry in VR. However, each of these methods has its drawbacks, such as susceptibility to ambient noise, lag and eye fatigue, or motion sickness. In this context, using the foot as an input source emerges as a promising solution for hands-free text entry in VR. Our research aims to explore the flexibility and applicability for food-based text entry techniques for VR environments, guided by the three research questions. To answer these research questions, we implement food-based text entry, carrying the 5 design considerations: applicability, learning ability, efficiency, accuracy, and fatigue minimization. Under these considerations, we use the quarter keyboard layout and place it directly in front of the user's view to ensure it is visible. We have included 2 text entry methods, tap and word gesture, as both have good performance in other research. Specifically, we use foot movements to navigate and position the cursor over desired keys, followed by a toe tap to select. To trigger foot movements accurately, we employed the HTC Vive tracker, ensuring precise and reliable detection of user actions in VR environments. To integrate foot tapping into VR, users tapping with their feet on foot-operated keyboard, and the tapping process is visualization in hand-mounted displays. Our exploration began with a preliminary study aimed at assessing the flexibility and learning ability of text entry techniques in both sitting and standing postures. We introduced 2 distinct single-foot text entry techniques, foot tap and foot gesture, designed to aid us in achieving our objectives. Foot tap functions as a discrete text entry method. User can select desired keys on the foot-operated keyboard by moving their foot on the floor and confirming their selection with a toe tap. Foot gesture adopts a word gesture method inspired by touch-based keyboards. Users initiate the gesture with a toe tap, tracking the shape of the word as their foot slides on the floor. Another toe tap concludes the gesture, after which users select the target words from candidates by moving their foot and toe tapping it. According to the results, we have 4 findings. First, we found user could enter test with tap and swipe-based tapping method in sight and standing positions without requiring extensive learning. However, it is less flexible or practical to perform foot tapping in a standing position for a long time due to physical fatigue. Second, compared to tapping via only one foot, participants were more expecting to coordinate and utilize both feet for text entry, which may help to reduce leg fatigue and improve the precision of selection confirmation. Third, short, simple text entry tasks are more appropriate when standing, such as entering passwords and setting short messages, especially using foot gesture. In the seated position, lightweight text entry tasks were more feasible, as there was no need for the legs and feet to help maintain body balance. Fourth, the swipe-based approach tends to involve less fatigue compared to the tap-based approach in standing posture. However, the swipe-based approach, its inflexibility may hinder its use in certain cases, such as typing some short words. Based on the findings from the preliminary study, we improved our foot-based text entry techniques from the following 3 aspects: shifting from unit-based to biped-based text entry, modifying the rectangular layout to arch-shaped for tap-based text entry techniques to reduce the leg fatigue, integrating a tap mechanism into the swipe-based text entry approach to solve its inflexibility. We designed an arch-shaped keyboard inspired by the physiological structure and movement patterns of users' feet. This design choice is rooted in the observation that users tend to rotate their feet around their heels rather than dragging them across the floors, minimizing knee joint involvement and horizontal foot movements. With the arch-shaped keyboard, users can pivot the ankle joint to reach keys close to the cursor position, and employ a combination of ankle and slight knee rotation for keys at a great distance. FeetSymTap provides users with two cursors, each representing one foot. Users select characters from a virtual culture keyboard through foot movements, confirmed by a toe tap on the corresponding foot. This design mimics tapping with both hands, promoting fluid and coordinated tapping to prevent strain on a single foot. Symmetry in foot gestures is crucial as users naturally alternate between feet during interactions. FeetAsymTap introduces an asymmetrical bipedal text entry technique, where the right foot controls cursor movement and character selection, while the left foot confirms selections with a toe tap. This approach streamlines the typing process by allocating distinct tasks to each foot, minimizing potential conflicts during input. FeetGestureTap combines swipe-based and tap-based method, with the right foot handling word-level gestures and the left foot managing characters input. Users initiate word gestures with the toe tap on the right foot, choosing the word shape by sliding the foot, and completing the gesture with another tap. Importantly, while the right foot gestures, the left foot controls cursor movements, but cannot perform taps, ensuring distinct rules for both feet. To prevent interference between the feet during movement, the foot-operated keyboards for each foot are intentionally positioned differently, like FeetSymTap. A rectangular keyboard layout is more suitable for swiping as it encourages relatively straight trajectory for swiping gesture. We conducted a user study to evaluate the three biped-based text entry techniques. According to the results, we have three findings. First, the outcomes about text entry performance affirm the proficiency of the three biped-based techniques in achieving an acceptable path of input for hands-free input in VR. Second, we found that bipedal tap-based techniques significantly outperformed the swipe-based technique in terms of tapping entry rate, mainly due to the alternative use of the feet. Third, coordinating tapping and position on the same foot is demanding and can be disruptive to smooth movements, potentially affecting accuracy. The frequent transition between toe tapping and lateral movement introduce complexity, which may lead to errors. On our previous results into user studies, we summarized the 5 design considerations for foot-based text entry. In our research, we have found that minimizing leg movement is essential to prevent fatigue and maintain typing performance in VR environments. Aligning the keyboard layout with natural leg and foot motion paths ensures comfort and efficient interaction, reducing the risk of strain and discomfort. Our arched keyboard layout contributed to lower physical demands and improved accessibility of target keys in the tap-based techniques. We should encourage users to alternate between feet for tap, as it can distribute the load evenly and reduce fatigue. The non-dominant foot is better suited for relatively simple tasks like typing rather than complex tasks such as precise key positioning or tracing. The dominant foot can be assigned more complex tasks and those requiring precision. Wheel swipe selection offers more versatility. It requires continuous and coordinated leg movements, making it more physically demanding and less suitable for frequent foot switching. Users prefer simple, easy-to-perform actions for repetitive tasks like text entry, explaining why FeetGestureTap did not perform as well as FeetSymTap and FeetAsymTap in text entry and subjective feedback. The above is the share of our work. If you have any questions, please contact us by email.